All right, lesson 32. Okay, so we in map 10, or 10C, we've already done these, right? This is really SOHCAHTOA, right? So we've kind of done that quite a lot. So we're just going to get a bit more into it. So let's relate our SOHCAHTOA sine ratios to the unit circle that we just learned. All right, so if we said sine theta is equal to opposite over hypotenuse. Well, remembering, looking at our unit circle here, right, that r, we're calling that 1, right? That has a radius, like the radius is 1 on this unit circle. So that'd be 1, right? And if I'm looking at this angle, opposite over hypotenuse, well, in this case, this would just be, opposite would be our y value, and then our hypotenuse would be our r value, which is 1, right? So what we can say here is that, sine theta is equal to y over r, or y over 1. So in this case, sine theta is going to just be the same as, is equal to y, sorry, is going to be equal to y. So sine theta and y are going to be the same thing. Like, so whenever we see sine theta, your guys' brain should be saying, okay, sine theta is my y value. That's what it's going to be for these unit circle questions. Similarly, right, when we look at, cos theta. So cos theta is equal to adjacent, right? So adjacent side's this one, over hypotenuse, which is r. So that's going to be x over r. But our r is equal to 1, so it's really just going to be x. So whenever we see the word cos theta, you guys can really assume it means our x value. So you could be like, okay, that point right there, that x, that's cos theta. Be the same thing. And then a y value there, that'd be sine theta. Same thing. All right, and then tan theta, well, tan theta, opposite over adjacent, that's going to be, well, our y over our x. And another way of saying that is sine theta over cos theta, right? We've kind of determined that for the first one. This is actually going to be an equation on your formula sheet. We won't really use it too much yet, though, but yeah. So that's that. Now, yeah, so, okay, going to the next one here. All right, so now we're going to talk about tangent. So we talked a bit about cos there. Let's talk about tangent here. And really why it's called tangent. Well, if we drew a straight line, we'll get a straight line here. And it went from here and made a line that was tangent to this one. That's not that tangent, but it'll do. Pretend that's tangent. So a line is tangent to that circle, right? All right, so if we did that, and then I said, all right, so let's go and make this line here, this triangle. If I went from here, oh, I got that stupid thing. What was that? Okay, so if we looked at, let's say, this point from here to here, right? And this is 30 degrees. And we want to know what tan of 30 degrees was, right? Well, one way of thinking about it, probably the easier way of thinking about it when we get doing these questions, is that tan is going to be equal to the opposite. So remember from last lesson, the opposite in this case would be a half on this side for a 30, 60, 90 triangle. And this side would be root 3 over 2. Okay? So we can figure out what tan theta would be equal to. Or tan of 30 would be equal to just by going opposite over adjacent. But I just want to kind of show you, if you extend this line here out to here, right? And then, but you know what? Let's figure out what the number is, and then I'll kind of lead into what's going on there. It's not really that important. It's just kind of cool, but not that important for you getting the right answer. All right, so let's figure out what tan 30 is. So if I went tan of 30 degrees, and I want to get this answer, yeah, this is like an exact answer here. Well, I can say it's going to be opposite over adjacent, or y over x, right? In this case, so tan 30 degrees is equal to, my y value is going to be a half, right? This is my y value along the side there, over, and then root 3 over 2. Root 3 over 2. And then remembering, dividing by a fraction is the same as multiplying by the reciprocal. So we could say tan 30 degrees is equal to 1/2, equal to 1/2 times 2 over root 3. And then our 2's cancel. So we end up with tan 30 degrees is equal to 1 over root 3. But then we don't really like it with the square root in the bottom there, so we want to rationalize the denominator. So I'm going to multiply this by root 3 over root 3. So we end up with tan of 30 degrees is equal to root 3 over 3, right? So root 3 over 3, that's what tan 30 is equal to. So now I just want to kind of show you what that means, just as a visual way. So what that means is that at 30 degrees, if you made a line out to the tangent line, right? That's saying that, oh, if we did that, this length here, my x value, that's going to be equal to 1, right? That is just my unit circle. So then my y value that comes out of this, that's going to be like my tan. That's going to be the same thing, that length. If I made the triangle go all the way out to there. Then I could say this point here was at 1 comma, and then our number that we had there, root 3 over 2. So that length would be root 3 over 2, right? And then if we did our 45-degree angle from out there to out there, well here, I'll kind of show you what we'd end up getting if we would have made our triangle here again, right? So if we made our triangle there and at 45 degrees, this would have been tan of 45 degrees is equal to, so remember this point here, both of them were root 2 over 2, right? So root 2 over 2 over root 2 over 2, well that equals 1, right? Anything divided by itself is just 1. So tan of 45 degrees is equal to 1. Another way of thinking about that, like I said, is if you drew a line all the way out to the tangent line, right? Well, this, my x value will be 1, because that's the value to there, right? That is 1. And then if I want to know what this side length is on this, well, that's 1, right? It's a 45-degree angle. This side would be exactly the same. So tan of the angle would be the y value if it was going all the way out to a tangent line. That's where the word tan comes from, right? All right, so that's kind of the y. You won't really have to do any of this like tangent line stuff if that didn't make any sense. But yeah, it's helpful to think about anyway. Okay, so I'm going to move on from that. We'll maybe bring that back up again when we start graphing these things in a later lesson. All right, so reciprocal trig ratios. So it kind of is exactly what it sounds like. So they're just flipping them upside down, but we've got some new symbols here now. So we've got a new thing called secant, right? SEC of the angle. And secant is just cos flipped upside down, right? So normally it's cos over 1. Now it's 1 over cos. Cosecant is equal to 1 over sine. And then cotangent is equal to 1 over tan. So you guys have probably seen these symbols before when you hit the trig number, if you have a TI inspired, or if you push second on a TI 83 or 84, if you go second function amendments, you'll see them like written in yellow or whatever color it is. All right, so just a way of memorizing these things though, that like you have these on your formula sheet, but just you'll be using them so much that you'll probably want to memorize them. I kind of think that since these things are inverse of each other, or reciprocal, sorry, they're opposites. So I've got an S here and a C there, right? Cos. It's like the opposite would be secant. You'd think it'd be the other way, right? So that you can remember them easy. But and then cosecant. Seems like it should be with cos, but it's not. Cosecant is with sine. So cosecant and sine, so they're like the opposite symbols of each other at all times. And then cotangent is kind of the one you would think it would be cotangent. It's like tan, cotangent, yeah. All right, so yeah, you guys will need to kind of memorize those, like which one goes to which. All right, so let's do some questions here. It says, determine the value of secant of 200 degrees round to 4 decimal places. So round to 4 decimal places, means we get to just plug it right into our calculator, so this one won't be too bad. So if we write it out here, I'm just gonna go to this, I'm gonna zoom into this more room here. Okay. So I'm gonna write out secant of 200 degrees is equal to, well, that would be the same as 1 over cos of 200 degrees, right? Because secant is the inverse of cos. So then if I just plug that right into my calculator, you should end up with negative 1.0642. All right, so just while I'm on this, do you guys remember what a negative angle means? Or sorry, I guess it's not a negative angle, this would be a length. Sorry, never mind. I'll leave it at that. All right, so yeah, negative that. So let's move on here. Determine the value of cotangent negative 3 pi over 5, round to 4 decimal places. All right, so what I'm going to do, you guys probably could just write in your calculator and type in cotangent of this. We could have done that for the first one too. But if not, the other way of writing it, so cotangent theta is equal to 1 over tan theta, right? So you can just type it in that way too, 1 over tan negative 3 pi over 5, and you should end up with 0.3249. Plug it all in. All right, so those ones are pretty straight up, just plugging them in. They get a little tougher here now. We have to start kind of thinking about our unit circle for these ones now. So it says, for what value or values of theta does tan theta equal negative root 3? So this is a point where people get confused, but they don't even know what they're looking for, right? We're looking for this. And remember, negative root 3, that's not an angle, right? That's really like it's a ratio. It's a number that we're getting out of this thing, right? It would really be the y value if you had a line that was tangent to our unit circle, right? Or you could think about this as being sine theta over cos theta, right? It's a ratio of some kind, it's a number. So we need to figure out what our angle would have to be for this. All right. All right, so like I said, on the unit circle is kind of where we're going to want to be. So I'm going to bring up a unit circle. You guys have yours. If you want this one, and I give it to you, I'll probably give you this one too if you just typed it a little nicer. So what we're really after here, right? We're looking for what angle, right? So what angle would this thing be? So remember, these are angles. I can't write on this, but like this is an angle, right? 120 or 2 pi over 3, right? And what we're looking for is, so tan, right? Tan is going to be opposite over adjacent, or y over x. So we're really saying, where does it happen that we're going to have our, geez, hopefully you can see my cursor there, the y value, so something like this, right, root 3 over 2, over our cos value, or our x value, sorry, would be, that should be root 3 over, or sorry, negative root 3. So if I go back here, first off, what I'm going to do is say, okay, where does this happen? Where, this brings us back to the cast rule thing, right? Cast, so maybe you forget that, that's fine. Cast is where things are going to be positive or negative, right? So the way this works is if I say, okay, where is tan negative? All right, well, tan is going to be, if I look at my cast rule thing, it's going to be positive here and here. So that means by default, it's going to be negative in this quadrant and this quadrant, right? In the opposite quadrants. All right, so just to give you a heads up of what we're looking for here, our answers are going to be either, because it's a unit circle and that's like, it's not going to be some random number, it's going to be like one, like this one, or this one, and then it's going to be this number, or this number. Those are like my possibilities, right? I know I'm in the second quadrant, and I know I'm in the fourth quadrant, that's where it's negative, and it's going to be those numbers. So I'm saying, okay, if I take, well, let's say this one, if I went root 2 over 2 divided by root 2 over 2, that'd be 1, right? That'd be negative 1 technically in this case. That's not negative root 3, so it's not that one. really, if I'm looking at it, I'm thinking this one, right? Root 3 over 2 divided by negative a half. Let's see how that works out. So if I go back over here, and I go, okay, tan, if I wrote it out and said, okay, tan of, let's say, was the 2 pi over 3 one that we were looking for, right? So tan of 2 pi over 3, well, that would be root, right, the opposite, or the y value, root 3 over 2, divided by negative a half, which would be the same thing as tan 2 pi over 3. I'm just writing it here, this 2 pi, like, this is my option, this is what I'm saying, hopefully it is this one, is equal to, and then that'd be the same thing as root 3 over 2 times negative 2 over 1. So those cancel, and lo and behold, I end up with negative root 3. Right? So that's right. So this is going to be my answer, right? 2 pi over 3 is what my answer is going to be there. So that's one of them. So, but it says between 0 and 2 pi. So remember, so I just found this one, right? I found this side here. My answer there was 2 pi over 3. So that's one of my answers. My second answer, just to narrow it down here to look at it, right? It's either going to be 11 pi over 6, 7 pi over 4, or 5 pi over 3. So remember, it's the y value divided by the y value divided by the x value. That should give me negative root 3. So it might be this one, right? But like this would be a different thing. This would be negative a half divided by root 3 over 2. So it's got to be this one, right? This is what we're after. So let's go back. So it's going to be 5 pi over 3 is my other answer. 5 pi over 3. Okay, so the other answer is 5 pi over 3. So those are my two values for theta. I mean, I probably should have said theta is equal to in that case. Okay, hopefully this is starting to make sense. We got to do a lot of it to kind of get used to it. And remembering, you guys don't have this unit circle on the exam either, right? So little thing that I would do, you gotta kind of memorize it using the patterns and everything else. If I was going into like the diploma or into my exam, I would make one pretty quick, right? I think when you got good at it, you could make one in about like 5 minutes or something, because it's gonna be handy once you have it all made. All right, so I'm gonna go back here. All right, so number 4. For what values of theta does cosecant equal root 2? All right, so I look at my unit circle, I'm like, cosecant, what the heck am I talking about here? I don't know that one. But let's rewrite this. Instead of cosecant, well, right here, cosecant theta is equal to root 2. I'm going to rewrite this as 1 over, now what is it over? So cosecant, what's that the reciprocal of? A sine, right? Sine theta is equal to root 2, right? So this is saying the same thing. Well, if I rearrange this, I think I'm going to get a better view of what sine theta is equal to, because I can use the unit circle to figure out what sine theta would have to be. So if I rearrange this guy, do that here, this would end up being 1 over root 2 is equal to sine theta. If you just I brought the sine theta up, right? Root 2 down. Okay. But that's not on my unit circle, right? 1 over root 2. But if I rationalize the denominator, I end up with root 2 over 2. That one should ring a bell. That's a common one that comes up, right? This happens at 45 degrees, right? At all my 45 degrees. So remember root 2 over 2? That happened at 45 degrees, root 2 over 2. Okay? Oh yes, but the other thing, you might be saying, but which root 2 over 2, right? How do I know like which one? Remember, sine theta is my y value. So if I'm looking at this one, that's that one right there, right? Root 2 over 2. So if it would have said cos theta, that would have been that one, right? Sine theta is my y value. So sine and y are the same thing, and cos and x are like the same thing. So just keep that in your mind. All right, so where is sine theta equal to root 2 over 2? So again, using my cast rule thing here, right? It's going to be, so if I did cast, where is sine positive? Because there's a positive out front here. Well, that's going to be here and here. All right, so my angle then The angle would be at, and it wants it in degrees, the way it's written here. It's going to be at 45 degrees, right? But then it's also going to be at, you'll get coupled with this, right? 45 degrees is this one, but then it's also going to happen over here, right? That's root 2 over 2 is positive right there, right? At 135 degrees. Okay, if you need to, you go 90 plus 45 to remember 135 there, right? All right, so it's going to be 135 degrees. Okay, so that's the answer for that one. Okay, determine the value of the other 5 trig ratios if secant theta is equal to -5 over 3. So, and theta is between 0 and pi. Okay? So if I'm looking at this, what I really need to do here is, well, let's rewrite this. I don't like it written as secant theta. I'm going to write this as, so the opposite of secant is cos, right? So let's write it over here. So 1 over cos theta is equal to -5 over 3. And you'll start to notice here that 1 over cos theta, like what happens with these numbers is they just flip upside down, right? I could have read the math said cos theta is equal to -3 over 5, right? I could do that. But either one, you could write it out like this and then rearrange. But at the end, cos theta is equal to -3 over 5. Okay? Now, this is going to be a little bit helpful because remember, like I can see this, right? So cos theta, if I did my SOHCAHTOA thing, right? Cos is opposite. So, right, this is the cat part of the SOHCAHTOA. Sorry, cos is adjacent over hypotenuse. So this is my adjacent, and this is my hypotenuse. Or the 3 is my x value, and the r or the 5 is my r value, or my hypotenuse in this case, right? Maybe this will help with a picture too. So let's make a picture. Draw. Just a simple one here. So if I was figuring out where this is happening, right? So my x value is -3, my r value is 5. So this isn't a unit circle anymore, by the way, too, right? Because we have an r value of 5. That would be 1 if it was on the unit circle, but it's not. All right, so -3 means it would be an x value like that over 3, right? 3 to the left. And then our r value would be 5. So where is that going to happen? Well, that would happen here, right? Where this was 5 and this was -3. But it would also happen down here. So as of right now, it looks like I've got 2 answers going on. That's where this part of it came in, right? It's saying it's between 0 and pi. So this down here, that's not an answer, right? That we only have 1 angle in this case now. All right, so I've got that, and then I've got this side, right? So the point is here, if I knew what my y value was, what the green line there was, then I can just use my SOHCAHTOA and my trig ratios and just write them all down. So I'm really in need of this. Well, hopefully this looks familiar to you. This is Pythagorean theorem to figure out that one. So let's go 5 squared minus 3 squared. You could have called that -3 if you like to, but we're squaring it, so it doesn't matter. Is equal to, we'll call that y squared. Okay, so if we do that, what do we end up with here? We end up with, oh yeah, that's an easy one. 25 minus 9 is equal to y squared, so 16 is equal to y squared, so y is equal to 4. Right? So now that we know that, we pretty much got it all together. We just need to write them all out. So we've got cos figured out, right? That's what cos was. Now we've got to figure out, let's do sine, right? So sine theta is equal to opposite over hypotenuse, right? So we said that that was 4, right? The opposite was 4. This is 4, right? 4 over 5. 4 over 5. It will be positive, right? 4 going up. Okay, let's do the opposite of sine theta now, or the reciprocal. So that's going to be cosecant. So cosecant theta is equal to, well, easy enough, flipped upside down, 5 over 4. So those are good. Now tan, so we'll do tan theta is equal to, tan is opposite over adjacent, or y over x. So that's going to be 4 over -3. And then cotangent theta, -3 over 4. Just flipped upside down, right? And that should be good. We got our other 5 trig ratios all there. All right, hopefully that made sense. Yeah, just all of these questions. There's lots of practice there. A lot of them are quick, so hopefully it doesn't take too long. All right, I'll end it there.